Find the linearization of f of xy is equal to x square minus xy plus y square by 2 plus 3 at point 32. Now, formula for linearization is L of xy is equal to function f at x naught y naught plus partial differentiation of function f with respect to x at x naught y naught into x minus x naught plus partial differentiation of function f with respect to y at x naught y naught into y minus y naught. Here x naught y naught means the given point 3, 2. X naught is equal to 3 and y naught is equal to 2. Now first we find function f at x naught y naught. They given that function f of xy is equal to x square minus xy plus y square by 2 plus 3. Function f at x naught y naught means function f at in the place of x naught is 3, in the place of y naught is 2. That means in the place of x we put 3 and in the place of y we put 2. Then we get in this function in the place of x square 3 square minus in the place of x 3 into in the place of y 2 plus y square means 2 square divided by 2 plus 3. Then function f at point 3, 2 is 3 square becomes 9, 3 into 2 is 6, 9 minus 6 is 3 and 2 square by 2 is 2, 3 plus 2 is 5, 5 plus 3 is 8. Then we find partial differentiation of function f with respect to x. This is the function f of xy. Partial differentiation of this function with respect to x is differentiation of x square is 2x. Partial differentiation of minus xy with respect to x is minus y. Partial differentiation of y square with respect to x becomes 0 and differentiation of 3 becomes 0. Now we find partial differentiation of function f with respect to x at point x naught y naught. That means partial differentiation of function f with respect to x at point 3, 2. In the place of x naught there is 3 and in the place of y naught there is 2. So partial differentiation of function f with respect to x is 2x minus y. In the place of x we put 3 and in the place of y we put 2. Then 3 2s is 3 into 2 6. 6 minus 2 becomes 4. Now we find partial differentiation of function f with respect to y. In this function we differentiate this partially with respect to y. Then we get partial differentiation of function f with respect to y. Partial differentiation of x square with respect to y becomes 0. Partial differentiation of minus xy with respect to y is minus x. Partial differentiation of y square with respect to x with respect to y becomes plus 2y by 2. 2 cancels and y remains. Partial differentiation of 3 with respect to y becomes 0. This 2 and 2 cancels and we get minus x plus y. Now partial differentiation of function f with respect to y at x naught y naught is equal to, that means partial differentiation of function y at 3, 2. That means in place of x naught 3, in place of y naught 2. Now we get partial differentiation of function f of y now we get partial differentiation of function f with respect to y, that is minus x plus y. In the place of x we put 3 and in the place of y we must put 2. Minus 3 plus 2 becomes minus 1. Now we apply this in the formula for linearization, that is L of xy, but that means linearization of function f of xy is, in the place of function at x0 y0 we what get, f at x0 y0 we get 8 and plus in the place of f of x at x0 y0 is we get 4. Partial differentiation of f with respect to x at point 32 is, that is 4 into x minus, in the place of x0 there is 3 plus f of y, in the place of f of y at x0 y0 there is, we get minus 1 into y minus, in the place of y0 they given that 2. Then linearization of function f of xy is equal to 8 plus 4x, 4 into 3 12, minus 12 plus into minus minus y plus 2. Then linearization of xy is equal to 4x minus y minus 2. This is final answer. This is linearization of xy, that means linearization of function f of xy.